All right, so determine linear or exponential if we were talking about the sequence rather than the function. Remember the difference between the function. If I'm talking a function, it's usually continuous with values in between, but a function can represent the same way to calculate a sequence. The sequence would just be discrete, where we're only talking the 1, 2, 3, 4. We plotted the points individually. So what did we look at? What did we notice when we looked at this that made us decide what to try right away? How many of you looked at it and went, this is definitely, obviously, blah? What? Yeah.
I thought it was decreasing by 5.
Okay, so you looked at it. The numbers don't go from really big to really small or really small to really big. They seem to be decreasing at what looks like probably a constant rate. Just glancing at it right away, most of us decided we're going to try a common difference right away, right? And we saw for a common difference that this was, say it again, please, Nick. It was decreasing by 5 over every equal length input value intervals, right? You also said those intervals had a width of 3. Now, this part right here, regardless of how much these intervals are increasing, is enough for us to say linear or arithmetic, because we had this language over equal length input value intervals. The output values change at a constant rate. It doesn't matter what the length of those intervals are to defend that it is arithmetic or actually linear. So we would say that this function is linear because over equal length input value intervals, the output values change at a constant rate. So this comes from here, and that's enough to defend linear, or in this case, arithmetic, right? Did anyone go the common difference? What, you have a question or you're... Okay, ask your question.
So, like, we get one of those in the test, we have to explain why it's linear?
Yes,
Oh.
But this is one of the ways you can do it.
Okay.
This way does not require you addressing that.
Okay.
As long as these are equal intervals and you have a constant rate of change, that's going to tell us linear. Who went ahead and found the common difference? Did anybody actually state the common difference? What is the common difference? Negative 5 over 3, because if we have a linear function, if we have an arithmetic sequence, we have a slope, correct? That common difference is the slope. Change in y over change in x. But we can also think of it this way. We went common difference plus common difference plus common difference, didn't we? It took 3 common differences to get a change of negative 5. And if I think about it that way, don't I also get that common difference is the negative 5/3? Okay. So your statement then could be based on the common difference that it is linear because there is or the sequence is arithmetic because we have a common difference of negative 5/3. Okay. Did we all recognize that was linear almost immediately, right? We like those ones. Linear are pretty easy to recognize. Okay. Then we have this frog problem. So I'm going to use two different colors because there's kind of two different ways we could have set this up. My frog scenario, if I use function notation, this is going to be the number of frogs on night N, right? How many of you used function notation to write this problem up? How many of you used sequence notation to write this up? Okay, so here you would define this to be the number of frogs on night N. Which one's better? Doesn't matter. Okay. You can do this problem either way. If you prefer the function notation, when you're talking about a function, but only looking at the discrete values for input values that work for a sequence. If you really like sequence notation because that tells you you're used to seeing it that way and it triggers your brain to go, okay, these are the sequence formulas, you're fine. Either way, what I know here is that f of 3 is 24 and f of 6 is 192, right? Or g sub 3 is 24 and g sub 6 is 192. Process is exactly the same. Now, again, let me see how many people use function notation. How many people use sequence notation? A few more use sequence notation, so I'm going to use sequence notation. Does that mean that your function notation is wrong? Nope. So what I know is that I can define any arithmetic sequence by starting at any previous term times r to the n minus k. So my g sub 6 can be defined in terms of g sub 3 times r to the 6 minus 3, right? So now g sub 6 was 192, g sub 3 was 24 times r cubed, correct? Divide both sides by 24. Please let me have got my numbers right. Is that 8? And so that means that the common ratio is 2. So now I can write g sub n. I can write it in terms of term 6 or term 3. Which one do you want to write it in terms of? Who? What? 3. Okay, so that means it's going to be g sub 3 times my common ratio, which was 2 to the n minus 3. So g sub n is going to be 24 times 2 to the n minus 3. You can leave your explicit formula here. You do not have to get back to the form that has the initial value. You do not have to convert it. This will get you every value in the sequence. Same thing is true if you did g sub n equals 192 times 2 to the n minus 6. You can start from any term in the sequence and define it. That's what I like about this formula right here. It allows me to start anywhere and they will work. So now the last question is, how many am I going to have on day 10? 24 times 2 to the 10 minus 3. So that is 24 times 2 to the 7th. What is 2 to the 7th? 128. And then when I multiply 128 times 24, that's a lot of frogs. It sure sounds like there's that many frogs. Am I done? No. What do I need to do? Okay, there should be 3,072 frogs on the 10th night in Mrs. Burleson's pond. Okay. Does that make sense? All right. So what I was gonna do yesterday when we were, or by yesterday, I mean Monday, by after we were done with the handing out of the forecasting stuff. Remember, I said there was one thing that I did on the semi-log day we were in class that I missed the part we were supposed to do, and we just wrote the equation. So that's what I want us to look at next. So this, I cut and pasted it, and I cut and pasted something that was cut and pasted, but I did it so that you can see this was number 6 on our semi-log in class, the tan sheet right here. Okay, this was number 6 on the tan sheet. I'm going to rewrite it because I know that is hard to see. That sheet said that y1 equals the log of 2200 times 1/2 to the t over 6. I should have probably moved that down a little bit. All right, so the directions said use your knowledge of log properties to transform this equation into the corresponding linear model. We did not do that. We just took the slope and the y-intercept that we found in the upper problems, and we didn't actually use log properties because I didn't read all of the directions when I was going through it in class. I had read the directions before, but sometimes I just teach and I miss it when I was doing that. So we're going to go through this. Log properties. Is this t to the 6th raising both of these to that power? It's only on the 1/2, so I can't bring it out front yet. Would you agree? But do I have a product here? What do I do if I have a log of a product? That means I can add right? Because didn't our property say log of A times B is log A plus log B? If I was multiplying with the same space, I was adding my exponents, and logs are exponents, right? Do I not know another log property that I could use to simplify this some more?
The exponent.
Exponent. What happens to the exponent? It comes out front because we had log of A to the B, right? If I'm raising a power to a power, I'm going to multiply my exponents. And since log is an exponent and B was an exponent, it goes out front. So this is going to be log of 2200 plus t over 6 times the log of 1/2. Do you agree that 6 is a number? Do you agree that log of 1/2 is a number? So doesn't this look like t is multiplied by a number? So I'm going to rewrite this so that it looks like slope-intercept form. Log of 2200 plus log of 1/2 over 6 times t. Do you see that? Can't I take the number and divide by the number, and that's going to get me another number out in front of t? Does this look like a slope? And does this look like a y-intercept? And if you type this into your calculator, log of 2200, is that what we got for our y-intercept on that worksheet when we did it before? And then if I type log of 1/2 and divide that by 6, was that the slope that we got? So those log properties actually get me the equate. I don't know why it's doing this, but it's doing, that's weird. You see it? You see the weird? That's weird. Anyway, everybody that's listening to the video is going to go, what? Because none of these dots and things that are showing up behind are showing up on my screen. They're only showing up here. So anyway, that might come in handy in the near future. So